following program is brought to you by the Ed Snyder Center for Enterprise and Markets at University of Maryland's Robert H. Smith School of Business. Welcome to the Ink Tank. Stay with us to get the inside scoop about technologies that could disrupt and challenge the way you do business.
Hello, I'm Christine Elson, and on this edition of the Ink Tank, we'll be discussing the growth of entrepreneurship in the space industry. We'll explore new opportunities that are emerging as the private sector moves further into the business of space exploration. Our guest today, Dennis Woodfork, is an expert in the space industry. He's an alum of the U.S. Naval Academy and the Robert H. Smith School of Business at the University of Maryland. Hey, Dennis.
Hey, how's it going?
Good. Thanks for joining me today in the Ink Tank. Now,
Thanks for
I
having
have
me.
to tell everyone that Dennis and I go back a few years. We first met in the Executive MBA program at the Smith School of Business. I'll just say, if anyone's looking for a top 10 Executive MBA program, check out University of Maryland. Anyway,
Go
Dennis,
Terps.
go Terps. Dennis and I had a great time in that program. That's where we got to know each other, and we've been talking a lot over the last years about what Dennis has been doing in the space industry, and I'm just super excited that he's here today to help us unravel some of the really fast developing aspects around the business of space, because there's a lot of new stuff going on there. So let me just start off by saying, Dennis, give us a little bit of an idea of why space is becoming a business. So in the past, when I grew up, space was NASA, and Dennis worked for a few years at NASA. So, but I thought of space as like, well, it's NASA, it's the government, it's a nation, we're going to beat the Russians. But that's not really the case anymore. So help us understand, why is that changing?
So that's a good question. There are, I think, several factors that play into that. One is, I'll just say, I think several of the entrepreneurs today, the big ones like Elon Musk and Jeff Bezos, were inspired as kids to see NASA and all the accomplishments, right? So you had people who their fire for space was seeded at a very early age. They went off and did other things, made their billions, and then they came back and said, you know what? It's 2000 and whatever, and we saw the last man set foot on the moon in 1972. It's really time that we do something to get humans and America back into space in a meaningful way, right? And I think that's the first thing, is just that passion and that calling and that inspiration. The other thing, if you start looking at some of the technologies, we've started to see in the last 20 years the advent of this standard called CubeSats, right, where you started with universities, Cal Poly and Stanford started looking at ways to modularize satellite components, put them together, and launch them cheaply into space. So we're starting to see these companies, and if you look at some of the companies like Bryce Space, who look at how investment and they track investments for space, they've really started to look at these technologies being an enabler for people to make money, right? And so you've got the passion by these entrepreneurs, and you've got the technology that's bringing down the barriers to some of the things that were only in the past possible by an entire country getting behind and putting their mind towards it.
So let's build a little bit on that, because basically what we're seeing is the opening of a new industry, a space industry. And whereas in the past it cost hundreds of millions of dollars to launch a rocket into space, what are we seeing here? Are we seeing that there's some sort of reduction in the cost of launching? Is it, besides having the ability to put these satellites together cheaply, how are we getting this stuff up there now?
Well, you've got, again, several factors. I think one of them is people now, the billionaires that are investing are really dedicated to this, and they don't stop when they have a failure. So they've been putting in their money, and they've had these really smart people coming at this technology for a very long time. I think one of the things you'll see in a company like SpaceX, and actually Blue Origin, that Jeff Bezos' company, is this idea of reusability. So if you remember a couple of years ago, they had a launch where they launched Starman, that Tesla, into space. And then at the very end of that dramatic launch, SpaceX landed 2 rockets basically in coordination right on the platform in the middle of an X, right? And the reason they did that, I mean, besides they wanted to, show the world, how it can be done, is I believe Elon really understood that in order to bring the price point down, you have to reuse everything that you can, right? And so they've, more than any other company that I've looked at, really taken a hard look at every single component and said, yeah, I know that in the past people paid this for that component. Why is it that price though? And their innovation is around bringing the cost down. So if they could buy things or manufacture it in-house and do things cheaper, then they do it. Now, all of that combined brings the price point down from hundreds of millions of dollars, right, which is what it typically costs before SpaceX entered into the fray. And they're around the price point of like 60 to 80 million, maybe even less with the reusability, right, depending on how many times you reuse the rocket. And then you've got folks like Rocket Labs with the Electron rocket. They're at a price point of 5 million. That's because they're launching smaller payloads into space. But again, the market's there. People want smaller payloads to be able to do a mission that they need and then dispose of it, right? And that's why it's so much cheaper now.
Yeah. So we have SpaceX sending up, creating economies of scale and being able to really open up this competitive landscape along with these other companies. So what impact is that having on the people that were in that space? Who was in there, and what is their response like now?
Well, so you've got there are 2 different, well, at least 2. There's the ecosystem is large, and I know we'll talk about that. But in terms of the impact for a launch being that cheap is all of a sudden you've got other countries, you've got investors that are looking to buy into big data. All of these entities now see the access to space is cheaper, and therefore it doesn't eat as much into the profit margin to do those things, right? And another aspect of that is the services that people can provide. So if you're a company that maybe doesn't want to launch things into space, but you think that the technology is right for you to blacken the skies with sensors, then all of a sudden now that profit model actually makes sense. And then you can sell that service, whatever it is, if you're doing, broadband internet, or if you're doing, I want to just, cover everything with, real-time video or whatever you want to do. Now all that makes sense for you to actually do because the cost of launch is cheaper. Go ahead.
So the people that are, for example, hiring SpaceX to launch all these rockets up, it's not just the U.S., it's people overseas. So whereas before they might say like, well, I'm a French company, I'm going to go with the French, national Airbus, whatever, now they're like, forget them, I'm going to SpaceX. Right. So they're basically getting all the contracts, right? And,
yes.
and sucking up the business because of their competitive advantage.
Yes.
Yeah.
And I think when you talk about a $400 million launch, that is a lot of money, right?
It's a lot of money.
But what you pay for in that, United Launch Alliance, when they were doing that, they're working to bring the price point down as well. I'm not actually sure where it is right now, maybe $200, $300 million. That's still a lot of money. Mm-hmm. But they would assure you, they had I don't think they've had a failure, right? Whereas when you take the gamble, it's a gamble, but SpaceX is reliable, but you're paying an order of magnitude less. And then you start to think, I can amass enough investors that they can see a return on their investment more immediately. They don't have to wait 10 years because they had to invest, $1 billion for me to get a couple of launches in, right?
Right, exactly. So the time is being reduced to get it in space. So you're accepting a little more risk, but at the end of the day, if it didn't get up, then you're not waiting 10, 15 more years for them to
Absolutely.
build the next rocket. So
That's exactly right.
Yeah.
Now, I think if SpaceX is I think they've turned around a launch, like the fastest turn time was like 48 hours. I mean, something absolutely just mind-boggling, right? When you think about what NASA does or what we did do with the space shuttle, and we'd wait, it was like $1.5 billion per launch or something like that. And you wouldn't launch right every couple of weeks, which is incidentally a funny story. That's how they sold this shuttle program, I think, to Nixon was, we'll be launching this thing
every
basically
week.
Every week,
We're
right?
going on rides.
Because the cost model said that if you do that, then it'll actually pay for itself, right? Now we never got there, unfortunately, but
it was a good model.
It was a good model.
It made sense.
But that's why you have a government to do those things and break down those barriers. I think there was definitely the space shuttle program had utility because it taught us that space is hard. Right. And in addition to what we did with the moon, it taught us that reusability in space is hard. And it's something that these companies, SpaceX and Blue Origin and others, have not forgotten. They've learned those lessons and they're asking the why questions now. Why do we have to keep doing it that way?
Yeah.
And that's what's driving the innovation.
Yeah, so that's cool. They're building on that knowledge. Let's talk a little bit about what you mentioned earlier. About people shooting millions of sensors into low orbit, basically in space. So, explain to me a little bit what are they putting there, and how many do they need, and what are we going to expect from that kind of operation, like a $5 million rocket shooting like 80 satellites into low orbit? Like, is that good?
Yeah. So unfortunately, with the Electron, their model is like 180 kilograms, like 400 pounds. Will put your small sat into orbit where you need it. What these other companies want to do is they would have to launch like the Falcon 9 or another large vehicle to essentially spray out these things.
Yeah, okay.
And so to get back to your question.
But.
Yeah. So what you want to do in low Earth orbit LEO, which is 200 kilometers up to like 1,200 kilometers, is essentially the best place that, from the cost model perspective and the technologies that we have for optical sensors, you want to be lower to the ground. That gives you a higher resolution, right? Now, in order to cover the Earth, right, which is what these companies want to do, because they want it. So let's think about the problems that you can solve if you darken the skies. If you're a country that worries about illegal fishing, right, in your neck of the woods, then you need sensors that can show you where people are doing that illegal fishing, right? And you need to be essentially covered 24/7. Mm-hmm. If you're a person that has a lot of land and you want to understand where water is, right, and you're a farmer and you want to look at your crops and you want to understand how it's changing over time. What the great thing about LEO is you're closer to the ground, right, as opposed to 22,000 miles in GEO. Mm-hmm. The problem is that, again, we're Newtonian physics, we're falling around the Earth, right? So as you're lower to the ground. At a smaller altitude, you're whipping around the Earth, 17,500 miles per hour ish, right?
Ish.
So you can't just have one satellite to cover the Earth, right? You got to have this massive coverage. Now, in the case of like SpaceX launched 2 Starlink satellites not too long ago in anticipation of launching not 10, not 100, but almost 11,000 or so satellites. Okay. And what that will do, right, there's going to be one constellation that's going to be lower or VLEO, I think at around 200 to 300 kilometers, and then another one that's going to be at like 1,100 kilometers up, still all LEO. Between the two, the one's got like 4,000 some odd, and the other one's got 7,000. The reason why you do that is that coverage ensures that everyone on the globe is able to get that signal, right? If you have what's called crosslinks where satellites can talk to other satellites, you can do things like beam information to one from the ground and then get that all through the constellation. So constellation management becomes a more manageable situation. But really, the reason why you want all those satellites in space is you want there to be no holes in your coverage at all.
At all. So what are the kind of policies that go along with doing this? Because it seems like right now it really has hit a accessible price point in some ways for people to just sort of start launching stuff up there and seeing what kind of data they can collect. And so, there's a similar race going on, on the ground. Like, let's just see how much data we can collect in this business model. And that's really where our value is. So is that similar to what we're going to see in these in this launching sort of extravaganzas that will be going?
Well, yeah, it's what happens is a company that wants to launch a satellite has to go to the FCC and say, here's my satellite, here's my mission. I want to go into this orbit and do this. And the FCC gets together and they say, all right, one, are you going to create more debris, right? Because one of the things about LEO, low Earth orbit, is there's been, we've been launching since the late 50s, 60s, right? And just proliferating a lot of debris up there. We can talk about that too. That's a whole nother thing.
Right.
But and what they want to make sure is that you're not just leaving trash up there because it's a common domain, right? It's one of the global commons.
Mm-hmm.
Now, what happens is if you don't prove to them that you can track your satellite and that you're not going to be stepping on someone else's part of the spectrum, they can actually say no. Now, we've had in the past, probably in the last year or so, there was a company called Swarm Technologies that actually launched despite getting a no from the FCC.
Oh, okay.
And so we're kind of in this uncharted territory where
you didn't shoot it down.
we
Seriously, come on.
Well, it's ironic because part of the problem they said was Swarm Technologies wanted to launch these things that look like hockey pucks. And they said, we're going to launch these. And the mission was the Internet of Things. They were going to basically try to connect, things for the internet, and they wanted to be that global network that's up in space. And, and the FCC came back and said, we don't think you can track your
hockey pucks.
So this company actually went ahead and launched 4 on an Indian rocket up into space. And then it got back to the FCC. Hey, didn't you tell them no? And they're like, yeah, we did. So we don't even know what's going to happen right now. We don't know if this is going to be the first company that's ever been their hands slapped because they launched these things.
Right.
No one knows the answer to that.
Yeah.
But to get back to what you were saying, I think the government understands that they need to make it as easy as possible for companies to operate in space and create these jobs and create these new technologies. And so starting, I don't want to say the Bush administration didn't do that, but when I was working for NASA, I got a first-hand chance to see the Obama administration and their push to actually foster these, policies that would allow companies to do it. So we call it space traffic management, right?
Yeah.
And the Trump administration has followed suit, and they've created a bunch of new policies meant at streamlining the process of trying to make it easier for people to launch things, people to operate things, and we just want to make sure we're mindful that we're not putting trash up there and leaving it.
So then they'll open the opportunity for someone to go and clean it up, right? So some of these satellites are meant to just operate for a couple of years, and then they're going to be replaced because the technology in them is, advancing. So you don't want to put something up there and think it's going to be good 10 years from now, right? So
and that's you're kind of talking about the OneWeb model, the one where you have these mega constellations. The great thing about them is you don't worry about your one satellite dying, right? It gives you, when you've got 7,000 or 11,000, yes, right?
All talking to each other. You actually prefer that some of these just burn up and you infuse the constellation with new technologies, right? Mm-hmm. So it's a continuous life cycle of putting it up, the service is there, and then you're upgrading it, right? Yeah.
And I think that's the model that OneWeb wants to do, SpaceX wants to do, is I don't worry that this one is going to burn up and, oh my gosh, I'm not going to have one out of 11,000 working.
Yeah, that's so cool. I mean, it really is. It's like just a whole new way to think about it, right?
And what it will do is it will bring down the cost of building satellites, right? The economies of scale. The technologies and manufacturing, all of those things are starting to come because people have dared to dream about putting 11. Now, there are people in the government that go apoplectic about that many satellites in space, right? You look up and you can't even see the sun because of these satellites. It's still a big space theory, but what that is doing, why I'm excited about that is because it's creating a whole new ecosystem, right?
Yeah.
And so, if you have that many satellites in space that are doing things, and say you have the ones that are higher they won't be coming down for hundreds of years. Mm-hmm. Say you wanted to service them, right? That's a whole new industry of satellite servicing.
Yep.
People that go up and they're the tow truck or the gas station or
right.
the whatever.
The whatever.
They change the
Upgrade.
tire.
Upgrade the
Right?
tech. Right?
That's right. That's exactly right. And that's a whole other, and
Yeah.
NASA is working on that. DARPA is working on that. There are entities in the government that see the value in that. And I think the great thing is investors do as well. They're investing in companies.
So let's talk. That's a good way to move into this idea of space infrastructure that we,
Yes.
which is another whole, thing. So we're talking about constellations, and we're talking about building a whole new ecosystem in space, and there's a huge amount of infrastructure that goes along with doing that. So what are some of the things that are happening there that are cool? Because building infrastructure sometimes everybody's like, oh, whatever, I mean, like.
Well, I will say before I talked about specific companies, I think one of the things I admire most about what I've heard and read about like Elon Musk and Jeff Bezos is they fully understand that in order for this to really the new space renaissance, whatever you want to call it, new space, in order for it to really firmly take hold, you have to build the infrastructure, right? You have to have people that are willing to do the foundational technology work that will enable people to manufacture things in space. And build transportation vehicles that will routinely go to space, right? Not once every month, but once every day, right? And they realize that. Elon Musk's goal is, for most people should know this, but if you don't, his goal is to colonize Mars, right? And he realizes that in order to do that, you need a whole infrastructure to do that. It can't just be one rocket that goes and comes back, right?
You better have something on the moon.
You have to have a communications infrastructure, right? And the government's been thinking about this too.
Sure.
But what I guess what excites me about this, the on-orbit assembly manufacturing, is there are companies that realize, hey, this is our part that we can do. So we've got Planetary Resources as a company that is actually, their business models, they want to go mine asteroids, near Earth objects that have rare metals and all kinds of things, right? That, I think it's Neil deGrasse Tyson said once famously that the first trillionaire that the world will ever know is going to be someone that
is an asteroid miner.
Asteroid miner, right? Because they'll bring back all these rare Earth elements, these platinum and whatever else, right, to the back to Earth. But if you think about it, if you were able to set up an infrastructure where you can mine resources outside of Earth, and then you've got in-space assembly, right? What in-space assembly does is it really frees you from the bonds and the barriers that we have of just launching in a payload fairing, right? So a rocket is only so wide around, right, across, and so you're constrained by the circumference, right, and the diameter of the rocket fairing. If you imagine some of the things that we want to do in the future, having these huge telescopes and things like that, you have to start thinking about how do you just bring up all the materials and then assemble it on orbit. So there's a company called Made in Space who is trying to do that. I think they've got a technology called Archinaut. And what they want to do is they actually want to just 3D print things in space. And you can then do whatever you need to do. You can optimize for your customer. And so that's part of the infrastructure. Part of the other infrastructure is communications, right? So there are people, we already talked about broadband, but think up instead of down, right? So people that create an internet network in space so that things can communicate between each other. You need that. You need power, right? So you've got people working on power generation and technologies in that space. And I think all of those things have to come together in order for it to be useful, right? We talked about Amazon before, about, companies like Amazon were made possible. And I read this in a book, Space Barons is a very good book. Companies like Amazon only possible because the infrastructure was there, right?
Right.
The post office was already there. The internet was already there. Credit cards were already there. Think of that same thing for space. You need to have all those pieces together. And then once that happens, then the real innovation will start, right? So we're in the beginning of the Renaissance, but hang tight for when people start doing that.
Yeah, that's so cool. So we might have a trillionaire asteroid miner, and then he'll throw the money into actually building the the next step that we need to, get a little further out.
That's right. I'm hoping it's my daughter so she can retire me.
Me too.
One of my kids.
I know. Yeah, I know. Really. Let's go to space. No, so cool. Okay, so when we think about that, building the infrastructure, that's a huge investment by a lot of people, governments, private parties, and so what? Just again, what are some of the who owns the asteroid and who? I mean, if you build it, I guess then.
So I think the Obama administration, the policy that came out during that time was, I think, what the policy actually says is if you can get to the wherever that body, right, you own whatever it is you mine off of there, right? They were very specific about that. Now, it's a far-reaching policy, right? Because no one's out there right now digging up platinum off of a rock. But the implication is that, once these companies actually, normally policy lags the technology, right?
Right.
Someone does something and they're like, oh, I guess we better figure out a policy to make sure we don't kill people, right? That almost happened with some of the space stuff that's going on, right? People were like, oh, well, now we've got private ventures trying to launch things into space. We probably should figure that out. Yeah. But with this one, it was interesting because it actually led the technology getting us there. And so this is for the United States ventures. No one can say, I own that out there because I discovered that rock, right? It's if you get there, you mine it, you own it.
Yeah.
And I think that's a great policy. It's something that, I don't think the Trump administration's thinking about rescinding or anything like that. But it's definitely going to foster people because they have that mindset, right? I'm going to go out there and get
Let
that.
It go.
So and I think they're those are the types of policies that we'd love to see more of. Is how do you make sure that people can see that they make money and investors will come.
So let's talk a little bit about the background. So you're orbital mechanical engineer, did I say that right?
Astrodynamics. Orbital mechanics works too.
Whatever. I mean, it's very complicated. And then you have a MBA. So what would you say to young people who are really interested in space? I mean, maybe they want to go the engineering route, but generally, what are some of the areas you'd say, oh, check this out? Maybe it's engineering, but maybe it's not, and give them some advice for their college.
I always like to tell people now that you should know more than one computer language. For me, it seems like, where we're going, and we didn't even talk about AI, right? Or anything like that, but AI will end up being a very large, a huge enabler of space exploration. If you think about what we need to do in order to make machines land autonomously or autonomously observe something where we can't actually directly control it, right? Because there's the tyranny of the speed of light, right? So if you're out past Jupiter, right, it's going to take a lot of minutes for you to joystick that satellite to turn it around and say, oh, I think I saw something there, right? You need, and the technology's coming, and where am I going with this? I think learning how to code is fundamental because those types of skills will translate to almost every aspect of space exploration.
Okay. From
guidance, navigation, control to communications to materials, right? All of these things, orbital mechanics, coding, I think, is number one for me. I would say other things, I always like to tell people don't forsake the arts for engineering, right? To the exclusion of.
Right.
I think the true innovators, the people like Steve Jobs and others, really had an appreciation for art and were able to infuse that, right? So if you're using both sides of your brain, I think a lot of innovation can come from that. And we need that, right? As you're starting to talk about these big architectures and structures in space,
design is
you need
so
architects,
important.
right?
Yeah.
You need designers.
Right.
So you need to make sure that you're doing both types of things.
Yeah, user interaction,
right.
how people
User
are going to
oh,
understand that.
that's so important.
Yeah.
That's so important.
Yeah, we're going to have another discussion about AI in space. I love these crossovers. It's like we're just covering some of those. Yeah. So,
but the other things, I guess, for chemistry, for understanding, right? We want to terraform Mars, right? So chemistry and biology end up being very important.
Mm-hmm.
It's really just, I like to tell my own kids, just be excellent at whatever you put your mind to. And if you're not afraid to fail, and if you're really a person that can keep your eye on something and go for it, I think you'll end up being successful in almost any industry.
Yeah.
But I've learned that from our MBA and just in watching our cohort and listening to professors and the people that have actually made it, right? Because we always do case studies on the billionaires, right? And the people that have made it. And it's like, well, what was the one thing that was, common to all of them? I think they never lost that passion, that flame, right? Mm-hmm. There's so many stories of how the incumbents wanted to keep people like Elon Musk out, right? Mm-hmm. And so you talk about the 5 forces and all of that, and what are the things that people need to do to be a new entrant. I think one of the things is he never let people saying no be the final answer. And I think that's with kids as well. If you get a bad grade on a rocket propulsion test, that doesn't mean that you're going to not be a good engineer. You got to pick yourself up, because that was me, and keep going.
Keep going.
Right?
Yeah.
And so, that's really the thing, is to keep that passion and to keep that focus on what you want to do, and you'll do it.
Yeah. Well, Dennis, I definitely will say that you are a person who has always shown unbelievable excellence in everything you've done.
Thank you.
And I've seen that from the day that we met and our, experience in the cohort, and I see you continuing to do it now. So we'll have to come back and have some more of these conversations.
Absolutely. I would love to come back.
The government is no longer the only customer for space exploration. Private sector is quickly expanding as billions of dollars of venture capital are making commercial space a reality. This is just the first step in the space industry revolution. Thanks to Dennis Woodfork for talking with me today. Until next time, this is Christina Elson in the Ink Tank.
You can subscribe to the Ink Tank on Spotify, Google Play, Stitcher, YouTube, and Apple Podcasts. Visit theinktank.org for a full transcript of this episode. A special thank you to the Kauffman Foundation for their support. From the Robert H. Smith School of Business at the University of Maryland, thank you for joining us in the Ink Tank.